All right. So problem 53 here, we're going to look at um, performing calculations and retaining the appropriate number of significant figures. Okay? And we've done this a little bit already because we've been in lots of different problems where we've combined numbers together and had to report the right number of significant figures, right?
Yep.
But it can be a little bit different when there's mixed operations that include addition and subtraction with multiplication and division. So let's see how we do. All right, so here we have 628 times 342. I'll get my calculator here so we can always see what's going on. 628 times 342, right? The answer is 214,776 according to this beautiful artistic calculator. Has so many beautiful ideas. But how many significant digits is in this first number here, Fred?
That's three significant digits.
Very good. And in the second one here?
Three also.
Very good. Now, do you remember the rule for multiplication in terms of significant digits?
I think I do, but you can remind me.
Well, it's just the number that has the fewest number of significant digits limits the answer to that number. So, for example, these both have 3, so the answer to the product of this problem here has to have only 3 significant digits. So the answer will have 215,000. All right, so it rounds up to 215,000. We can write this as 2.15 times 10 to the 4th, right? 1, 2, 3, 4, oh, 6, 10 to the 5th, sorry, 5th. 1, 2, 3, 4, 5. 2.15 times 10 to the 5th, okay? But this has 3 significant digits. There's no decimal place here to indicate that these are significant. And this has 3 significant digits as well. So after multiplication, you choose the one that has the fewest number of significant digits. Okay? Let's go on to B here. Here we have, again, we have 2 numbers being multiplied by each other. How many significant digits are in this first number here, Fred?
Oh, that's 3, right?
That's right. 5.36, that's 3. And over here?
That's 2.
Okay, so then if I put these into my calculator, 5.63 times 10 to the 2 times 7.4 times 10 to the 3. All right, so it gives me a large value that I should only take how many significant figures?
Just 2.
That's right. 4,200,000. So 4.2 million is our answer. And that is, again, because I can only take 2 significant figures because this one here has only 2 significant figures. All right, here's a division problem. Same situation. How many significant figures on the top?
Oh, is that 2 or 3?
Let's erase that there for us. We have three significant figures, right? 28.0.
So after the decimal point, if there's a 0, it's significant?
That's right. After the decimal point, if there's a 0, it's significant. So 3 on top. How many on the bottom?
5.
But the answer is only going to have how many then?
3.
That's right. So 28 divided by 13.483. So our answer only is going to have 3 significant digits, so we're going to be at 2.08. All right, D. Let's look at D. Here is the same type of thing. How many significant digits here?
4.
And here?
2.
All right, so our answer between the product of 8,119 times 0.123423, there we go, is going to have only 2 significant digits, so it's 0.19 is going to be our answer. All right, E there, this is addition. Now, addition is different, and it doesn't really help us a ton to count up the number of significant digits in addition. In addition, what we do is we line up our values that are in addition or subtraction. 14.98 27 point, is that 27,000? Wonder if they meant it to be 27,000. 27,340, and then 84.7593. 84.7593. So if that's 27,340, we line everything up according to the decimal point, right? So everything's lined up according to the decimal point. This is where this decimal point is here. And then we go this way. We draw arrows identifying where the decimal points end here, where the significant figures end. Now this 0 is not significant, right? You look at this value here, and that 0 is not significant. So I go this way until I get to the last significant digit, which is that one. Okay? So because this is the one that's furthest to the left, that is where in the hundreds place our significant digits need to cut off. So I can take 14.98, add 27,000, what is it?
340.
340, plus what?
Plus 84.7593.
Plus 84 point what?
7593.
7593. All right, so the answer there is 27,439.7393. But again, this, whoops, I screwed that 9 over a little bit. This has to be the spot where our significant digits end, because this is where they ended here for this number. So the answer is going to be 27440, and that's going to be our answer. Okay, next we have 42.7 plus 0.259. So how do I do this one?
Well, do you have to line it up again?
That's right. Every time you do addition and subtraction, you have to line it up. So 42.7 plus 0.259. All right. I'm going to put that in the calculator. 42.7 plus 0.0259. Answer is 42.7259. Now, how many of these digits do I keep?
Well, you cut it off at the tens place?
How did you know that?
Because the top one cuts off at the tens place.
Very good. This is the last significant digit here, so we need to cut this off at the tens place. So there's 2, doesn't round that 7 up, so the answer ends up being 42.7. All right? Very good. All right, 54. All right, number 54. Here we're going to perform some more calculations. Can you tell me, Fred, right off the bat, how many significant figures the answer is going to have?
It's a multiplication, right?
Yep.
Therefore, it's just the fewest number of significant figures between the two of them, right?
Yep.
And one has 3 and one has 2.
Right. So
there's only going to be 2 significant figures in the answer.
very good. So one has 3 significant figures, one has 2. So the answer only has 2, so it's going to be 2200, right? Using the 3 to round, no, sorry, 2100. The 3 doesn't round up this 1, so it's just going to be 2100. All right. What about this next one here?
That's addition and subtraction, so you got to line them up.
What do you mean line them up?
Write it down so that they're going kind of like top to bottom.
So like 0.147.
Yeah.
0.0066. I try to keep these nice and lined up really well. 0.012, because when I do that, I can see where the last significant figure is. I draw arrows to the last significant figure, and this is where the last one is here. This is where it's here. This is where it's here. So it's going to, the answer is going to be rounded to this last significant figure. All right. So 0.147 plus 0.0066 plus 0.012. My answer is 0.1656, and this 6 is going to round that up to a 6, so 0.166 will be our answer. Okay? 3 significant figures. All right. How about this last one? Or not last one. How about number C here, or letter C? How many significant figures there?
Our answer is going to be 2.
Very good. 38 times 95 times 1.972. Now tell everybody how you knew it was only 2.
Well, the first number, 38, has 2 significant figures. 95 has 2, and 1.792 has 4. So, because the lowest one has 2, the answer is going to have 2.
Very good. So 7,100 then is going to be our answer. Okay, so here is a problem where we're going to do some subtraction. I line them up, right?
Yeah.
15 minus 0.15 minus 0.6155. Okay, so 15 minus 0.15. Whoops. 15 minus 0.15. There we go. Minus 0.6155. All right, so the answer is 14.2345. My arrows go this way until we run out of significant figures. I have to round to this value there, so my answer ends up being 14. Okay, you see how that works?
Yeah, I got it.
All right, E. All right, so we're going to have 8.78 times this fraction, but we have to take this fraction and perform the function there first. Now, because this is not a mixed operation, meaning I'm only doing either multiplication and division or addition and subtraction. In this case, I'm doing multiplication and division. So I don't need to collect significant figures till the very end. Okay. If it was a mixed operation, let's see if we have any mixed operations in here. Here's a mixed operation, subtraction and then division. Then you have to collect significant figures according to your order of operations. But here, you can follow the order of operations and just use the rule for multiplication and division, which is what's the rule that determines the number of significant figures for multiplication and division, Fred?
It's the fewest number of significant digits, right? So we got 2?
2 or 3?
Oh, yeah, 3.
So 3 significant digits is the smallest number. All of them are 3, right? So our answer is going to have 3 significant digits as well. So the order of operations says I should do what's in the parentheses first. So I have 0.05 divided by 0.478. All right, times 8.78. Okay, so there's my answer, and I'm going to have 3 significant figures, so it's 0.918. Okay. F, just addition. So I line them up, right, Fred?
Yep.
140, 7.68, 0.014. I can add those up in my calculator. And then I have an answer, 147.694. I draw an arrow to the last significant digit. Where's my last significant digit here?
Oh, it's the 4, isn't it?
That's right, that 0 is not significant. So it's all the way over here at the tens place. So I cut off at not the ones place, but the tens place. And so this answer is going to be just 150. Okay. So G, subtraction, 28.7. Let's try that again with a fresh piece of paper. Here we go. 28.7 minus 0.0483. The answer is 28.6517. The arrows go this way. And that's where my last significant digit is on this number. So I have to round to this value right here, the tenths place. So 28.7. Okay, good. Here's our mixed operation one. So according to the order of operations, do you remember that? Please excuse my dear Aunt Sally, or PEMDAS, or whatever they use. What am I supposed to do first here?
In the parentheses.
That's right. 88.5 minus 87.57. Okay? So that is a subtraction. And the way that I perform subtraction problems when I'm trying to conserve or identify significant digits is 80. I line them up. All right. So 88.5 minus 87.57. Okay. So 0.93. I point an arrow to my last significant digit. It rounds off right there. 0.9. And now I've collect that significant digit and put that into the next operation. 45.13. This is just a division problem. 0.93. I have to collect that to 0.9, and then divide by 45.13, and my answer is 0.1994, but I only have one significant digit, right?
Yep.
So what's my answer?
0.2.
0.2. Whoops. 2. Ugh. 0.2 is going to be my answer with one significant digit. Okay, good stuff.